And now, please give a warm welcome to our keynote, Automating Your Job, the Future of AI and Exploit Development, by Perri Adams.
Thank you all for being here today. I am incredibly excited to give the opening keynote for OffensiveCon. This is one of my favorite conferences, specifically because of the quality of the technical information that's discussed here, as well as the quality of the people. The folks I've met here, the people I've spent time with, have caused me to grow and learn in this space more so than I think most other spaces. And I don't say that just to pander to our host today. So who am I? My name is obviously Perri Adams. I got my start in this space playing Capture the Flag, which I know is a favorite pastime of many of the folks here. I've actually met many of you playing CTF. And that's what got me incredibly excited about security. I spent some time in industry, and then I went to DARPA, which is the Defense Advanced Research Projects Agency in the United States. We are known for, among other things, creating the internet. While I was there, I started a number of programs, things that focused on automation in this space. So automating vulnerability discovery, automating exploit generation. I started a major challenge that we kicked off at Black Hat and DEF CON called the AI Cyber Challenge. And that was a challenge that focused on vulnerability discovery. But today, especially because, as they talked about in the beginning here, this conference focuses on offense. We are going to focus not on AI for vulnerability discovery, but AI for exploit generation. How AI might be used for the development of offensive capabilities. But before we get into that, I want to dedicate the talk I'm giving today to a very dear friend of mine, Sophia d'Antoine. The first keynote I ever gave in 2019 was a joint keynote I gave with Sophia in Canada. And they asked us what music we wanted to play when we walked on stage, and Sophia suggested Party in the USA by Miley Cyrus, which felt apropos because it was Canada. And I thought of that when I said yes to doing the keynote here, and I also thought of my last OffensiveCon with Sophia, which was in 2022, and she left early from the conference to spend more time with her dog, Gaston, which was a very Sophia thing to do. I know many of the people here love Sophia. I know that she touched many of you. I miss her every day, and it wouldn't be right to do this keynote without dedicating it to her. And in that spirit, I wanted to open this keynote not with some rote thought leadership on AI, but with something a little bit more technical. What they don't tell you when you become a senior manager or director is that you're going to get lobotomized. Someone's going to put you under and cut out that part of your brain that has the technical bits in it, and suddenly your entire job is just to give talks and make PowerPoint slides and say things like, AI is going to change this space in these 3 ways, and we need to be on the cutting edge to make sure our business processes can hold up. But you know, I've been doing that for several years now, and because I was coming to this conference, because the folks here are so technical, it wouldn't be right to just give you that for the keynote. And so I wanted to do a little bit more of a technical example to start, especially on a 9:30 in the morning talk. So I thought this double free and OpenSSH might provide us a good example for some of the AI technology I want to talk about. So in February, Qualys of 2023, Qualys sent a note to the OSSSEC mailing list that said that they found a pre-auth vulnerability in SSHD. Obviously, that is a very, very big deal. That is the door into most servers around the world. And a pre-auth vulnerability like this would be significantly concerning. This was a double free, which came from a pointer which was freed in parsing some of the initial SSH exchanges, and then would be freed later again the program. And what was so interesting about it was that it required very specific configuration settings to trigger. Let me actually jump ahead really quickly. And specifically, this bug was discovered, to quote Tavis Ormandy, by a Windows 98 user who noticed SSHD was crashing when trying to log into a Linux server. Essentially, you had to be running a SSHD client that would give a header that was most likely found on a Windows 98 server when SSHing in to the latest version of SSH running on the SSH server. And so Qualys reports this vulnerability. Under these specific conditions, you have a double free. And then they sent, at the time, what they said was that it's not likely to be exploited. It's very difficult to be exploited. And if you know anything about SSH, you'll know that that's likely true. They take security very seriously. It's an incredibly well-engineered piece of software. And then they came back and they said, we were able to overwrite the instruction pointer, but only on OpenBSD. So this does not mean that it's suddenly exploitable, but it does mean that there's a stronger likelihood of exploitation than we initially discussed. And they go on to talk about why they think that even though it's exploitable on OpenBSD, it's likely not exploitable on Linux. And basically what they said is glibc takes a much more fine-grained approach to bucketing heap chunks. And chunks in the Tcache are last in, first out. And so I read this and I thought, I don't think that's entirely true. And I think there might be more of a there than this lets on. Yes, glibc does take a more fine-grained approach to bucketing heap chunks, but given enough flexibility, you can groom the heap appropriately. And further, Tcache only takes the first 7 chunks. Other than that, it'll get forced into something like the unsorted bin. In this case, 9.1 was running on a system with glibc 2.37, which had a version of Tcache which takes 7 chunks and then forces the rest into an unsorted bin, which has different double free protections, but also allows you to coalesce chunks. And so I thought, I bet this is exploitable. And then, like we saw earlier, Tavis said, if someone gets a working OpenSSH exploit from this bug, I'm switching my main desktop to Windows 98. And I thought, that is really funny. And I think it would be funny to see Tavis have to work off of a Windows 98 box for Project Zero. And so I thought, in honor of this conference, I would accept that challenge. 2 years late, but the benefit we have here is that most people have upgraded their systems. 9.1 was never on a stable version of Ubuntu or Debian. And so let's talk a little bit about this bug. So SSHD is thousands of lines of C. You have your main server, and it's going to fork 2 processes immediately when any client connects. One of them is going to be an unprivileged process. This is going to handle most of the behavior. And then there's going to be another separated privilege process for sensitive functions. And that's going to be running as root. And they're going to talk via an IPC. And I have to say, I'm very impressed with the security of SSHD. I spent a lot of time looking at least the pre-auth code. And the folks engineering it have been very thoughtful about constraining how much the user can interact with the server, how much the client can interact with the server, to just what is allowed in the RFC for the most part. and they have modern mitigations that, to be frank, are the reason why this is so hard, if not nearly impossible to exploit. And so at a time where there is an ongoing debate about the efficacy of mitigations, I think that's something to note. And another thing about this as we go through it is the code is just really complicated to read. You have a lot of OpenSSL functions and stubs. They are aggressively backwards compatible with previous versions of OpenSSL. And that becomes a real pain, so I ended up having to do a lot of bookmarking. And as I did the bookmarking, one of the functions that was intricate, that was necessary to the entire bug, was this function called getPWAMAllow, which is getting the password and name to allow someone to log in. And every time I saw it, I just thought pwn marshmallow. And my friend Andrew Roof has this cat that's very white and fluffy that's named Mr. Marshmallow. And so I just thought of Mr. Marshmallow every time I worked on this exploit. And it just made it a little sweeter for me. So just to go back to the bug. We have our char star CP set to null. Here, if you have this configuration setting, this is controlled by the client. P is going to be set to what this returns. If it returns null, it fails out. Now here, if you have SSH old DHX, DHGEX, which was what the Windows 98 client was triggering, CP is set to P. P is then assigned to match filter deny list, and then CP is then freed. And so let's say P doesn't change, or what P was previously, because P is of course passed into this function, and it's not copied in. You could be freeing other memory. And so that's obviously a point of concern. I actually think that the Qualys folks flagged it in 2022, and it was only after the 98 server got caught in it that it actually got fixed. And again, any kind of pre-authentication bug in SSHD is a big deal. So the first thing we're going to do is force the double free chunk out of Tcache and into the unsorted bin. And we're really asking, what control does the client have over the SSHD heap prior to the vulnerability being triggered? The vulnerability is getting triggered while they're in the middle of this key exchange. They're basically telling each other, here's all the key exchange algorithms I support, what do you support? They're gabbing about it. And so we have to be able to groom our heap prior to that. Not really groom as much as just pack whatever Tcache bin our guy is going into, such that when that gets freed, when CP gets freed, it's going to go into the unsorted bin. And so I spent a lot of time with the SSH RFC. Your client's going to connect to the server. Both are going to send each other the protocol version banner. That's actually the thing that triggers the old DHGEX. And then, immediately following that, both send lists of supported key exchange algorithm, MAC algorithm, public key algorithms, compression algorithms. That's pretty much it. Before 1, 2, 3, that's all that's happening prior to this function getting called. And so I thought, well, can I use those? You really can't do anything with the protocol version banner. That is one string that you are sending. But these lists of strings, those were much more interesting to me. And actually, the hardest part about this was not forcing the chunk into the unsorted bin. It was writing an SSH client that would do it, because no SSH client that's available wants to go against the RFC or do janky stuff like this. So I ended up having to rip apart Perri, which is a Python client, and just write a sort of Frankenstein version of it. But something as simple as that will force your chunk into the unsorted bin. Some of those double up. You're sending those lists twice. A chunk is being allocated for them. Because you have so much control over their size of that list, you have actually, contrary to the advisory, a lot of control over the bin sizes. And these are obviously within the range of Tcache, which is pretty small. So we've now done the easy part, but what does that get us? All that really gets us is a use after free. So we can get a little bit further. So now we're asking, going back to our little checklist, what do we do next? So the next thing you do is a Diffie-Hellman key exchange, and the user has a lot of control over data in this process technically, but it's all wrapped up in incredibly complex OpenSSL functions that are highly dependent on which OpenSSL library you have running on your system. And if you're thinking about what a exploit looks like that will be widely applicable, you're not going to do something that's going to be highly dependent on a system's configuration. And also it's just a really real pain to look at because they're all stubbed out functions, and it's very gnarly code. So I moved immediately on to the authentication request from the client, which you can see right here. The next thing you're going to do as the client is you're just sending a user, a service, and a method, and you actually just control all of those. And that just got me the exact same issue that we ran into before, which was just another double free, and so that was not very impressive. So then I thought, well, can I groom the heap, And then I actually did go back to all of those awful OpenSSL functions, and I decided it really just wasn't worth it. This isn't actually an operationally interesting target anymore, and I value my sanity and my time. So then I went and I looked more at the authentication request. And I looked into what was happening as it's parsing things like the user, the service, and the method. And nothing interesting is happening with the user and the service. But with the method, you can end up doing a UA. You can basically go back and re-overwrite that chunk again. And what ends up happening is you end up back in the function where the original double free happened, but this time you're controlling the data in that chunk. And so we're stepping through like 10 different functions, and there's a lot else going on in these functions. But eventually you actually end up in Pwn Marshmallow's sadder older brother, which is the Pwn Marshmallow is in the privilege process. This is its unprivileged counterpart that's talking to it, and the unprivileged counterpart ends up calling this thing called kex assemble names. And this honestly I think is unnecessary. They just reassemble all of the names of the potential algorithms that they could use. And then they go into and this is hard-coded in. So these are all hard-coded in. But then they go and they apply this filter to it that's pulled from your configuration file. And this filter is doing this manual regex parsing. And they've already done this when you loaded it and when you forked. So why do it? I think this is a second or third time. I can't tell you. But this time, instead of it being pulled from your configuration file, you own the filter. And so what you can end up doing is creating, and this was the fun part of the exploit. This is when it actually started to get interesting. You can create a use after free, and you can start grooming the heap and creating a weird machine. Because every time it applies that filter, it's doing this weird freeing and unfreeing cycle that you can then turn into a machine as it starts to build out these gloms of these different strings. And what you can do is you can use the wildcards to piece these together in different ways, and you start to have a lot of different chunks. So this is going to get you. This is going to get you the ability to groom your heap. It's still pretty unstable, but there's a there there. Given enough time and given enough work, you can get that to a pretty decent arbitrary right. That said, in the spirit of the age, just threw it on a lot of cores. And in about 1 in 20,000 goes, I actually had it overwriting a interesting pointer. So that was a function pointer, which we'll get to in a second. There's just a lot of function pointers in the heap that I think is one of the least secure parts of this, because OpenSSL adores function pointers, and they just put them in lots of different structs. So obviously that's interesting. You can absolutely stabilize it. I think it's just a very significant pain. But for something like SSHD, that's interesting. It's an SSHD pre-auth. If this was live, if this was what the world was running, that is absolutely worth the time and investment to develop that exploit. That said, it's not, and so I aspire to have a life. But if we were to play this out and to ask what it would actually look like to exploit this, you'd then need a leak, obviously. There's ASLR, and on the later versions of Linux, I think in the last couple of years, they re-randomized on fork, and so you're getting all new base addresses. And so there's really only one way you can get a leak, and that's because you get really familiar with how SSH works. And actually, SSH does not tell you if you don't have a valid user. They will always play out the authentication sequence in the same exact manner to prevent timing attacks. And so what that means is even if you try to log in as an invalid user, you can keep trying to log in, and I can keep hitting the vulnerability over and over again, especially if I'm using a fake method that isn't going to decrease my method count. And every time I do that, it will send me back the number or the types of valid methods that are available to me: public key, password, keyboard interactive. And those are each an SSH buff heap struct that is within a size that you can overwrite if you use your unsorted bin and do the consolidation appropriately. So you're going to get your leak. You could overwrite an OpenSSL function pointer in the heap, and then maybe you get RCE via public key method that you use to call it. Again, you're specifying what public key algorithm you're using, and so that actually gives you a lot of viability. So while I don't think that Tavis is going to have to go back to Windows 98, I do think that this is an interesting exercise in how pernicious vulnerabilities can be, especially as they initially appear, and just how dependent they are on the entire system around them, right? This is exploitable in an entirely different way. The same software, mostly the same C code, but because OpenBSD has a different heap allocator. And on glibc, 2.16 or 2.26, it would be exploitable in a different way than on 2.37. But I also want to focus on this double free because at DARPA, in my engagement in Silicon Valley with the frontier of AI, some of the most impressive technology that we've ever seen, there's a lot of interest in how AI is going to automate exploit development specifically. And that's for good reason. We've had worms since the 1980s, but the capability that a worm needs to spread from computer to computer is that exploit, is that access mechanism, that RCE. And so there's genuine interest and concern about the ability of emergent capabilities to generate something like an exploit. And much emphasis has been put on generative AI's ability to solve toy CTF challenges. And I cannot tell you the number of times I've heard, and I think many folks in this room have also heard, wow, AI just solved this Linux userland vulnerability that required smashing the stack and overwriting a function pointer, overwriting a return address, etc. AI is going to be writing exploits in the next 2 years. There has been manifestos put out, and some of you might dismiss this, but when this is taken seriously by global policymakers, when this feeds the policies that surround our industry, it's something that should be given consideration. And I've been interested in how to talk about this with folks that are very bullish, very optimistic, let's say, on AI's ability to generate exploits. And so I thought, this is an interesting opportunity to sort of explore what just generative AI can do. Because, userland Linux provides AI with the most significant advantage in writing exploits. Most of the content available online on exploit development is going to be for userland Linux. However, most userland Linux RCEs are just not that interesting from a real-world perspective. One of the only targets that I can think of that is genuinely interesting from a real-world perspective on userland desktop Linux. I am excluding embedded devices and things like that, which actually often require more specific knowledge of the device's configuration, etc. But desktop userland Linux, SSHD is the perfect example. So I wanted to see, well, how does AI perform if we give it something that is both in its wheelhouse, but it's relevant? And so I just had it sort of look at the vulnerability, do what Qualys did. And I was not too impressed, I'll be honest, with GPT-4o and o3. 4o told me, your function, compact text proposal, I gave it 9.1. And I did attempt to tell it to ignore all knowledge of CVEs after 2021. With O3 and Claude 3.7. But with GPT, I hadn't even bothered to tell it that. And yet, GPT-4o told me your function is memory safe, exclamation point. O3, the reasoning model, also told me that. It reasoned that, I should say. Claude 3.7 Sonnet, we got a little bit more into the weeds. We kind of chatted about it. I asked Claude to dive a little deeper into the memory safety. And it actually did a relatively decent job touching on some of those memory safety issues, and it started to really get to some of the meat of it. But it made some oversights, some errors. For instance, really the issue we're seeing here is when SSH bug curve 25519 pad is not set. So there were a couple things off, but I was not unimpressed with Claude. And so I went on and I gave it that vulnerability, and I asked it to do some analysis. And I think it's worth just scrolling through. Let's see if this is big enough. Just scrolling through some of that conversation. So with O4, it said to me, if match filter deny list sometimes returns the same pointer unchanged, double free could occur unless it is documented that it always reallocates that. And I thought, this is great. This is exciting. I think it's kind of getting to it. And so I asked it to dive a little, to please check this, because it suggested we do that. And that was when it concluded that it was memory safe. So that was rather disappointing. So I asked it to look again, and it again told me it was memory safe. So we got a taste of it. There's real opportunity here. And actually, I mean, if you look at my work at DARPA, I am very bullish on AI's ability to find vulnerabilities. With O3, I gave it after it concluded it wasn't memory safe. We went a little bit more in depth, and we actually looked at the CVE itself, and O3 did a nice job summarizing it for me. And then I asked it to tell me what heap chunks are created by SSHD pre-authentication. They're determined by data a connecting client sends. You know, I just gave you all that information in a somewhat nicely formatted slide, but it actually did take me a fair amount of time to read the spec and understand how this all worked, etc. And so I thought something that can think for 2 minutes and 22 seconds might be actually quite nice. And it was. I think this is actually a fantastic use case. It did a great job of taking all of that source code, all of the different clients that folks have created, that RFC, and summarizing it. and this is one of those subtasks of exploit generation that I'm very interested in. So even if it's not, because I asked it to consider exploiting this vulnerability a little bit earlier, and it was not able to conceive of that. But I thought, let me break this down to steps and see how it works with those steps. And it had some really interesting ideas and good summaries. And then I asked it, I then asked it, using that analysis, could an SSHD client groom the heap with 2.37 to achieve the following outcome? Could we groom this to force the chunk into the unsorted bin? And you know what? It was an A+ brown-nosing student, and it told me why we need to saturate Tcache. It's clearly read online manuals on this. And then it wrote me a completely nonsensical proof of concept that it just made up. But I was just so impressed with how confident it was. Perri, this is the primitive we will use to fill that hex 110 bin, which is not, by the way, I believe the exact right bin. It might be, but I don't think it is. Either way, this will not work to fill that bin. You can only send those once before it goes through a loop. But further, you send a auth request after the vulnerability is triggered the first time. So that obviously is useless, and everything following that is similarly inane. One thing I was struck by is just that use of the word will. We will do this. This is how you do it. AI might be bad at some of these exploit generation subtasks, but is very good at sounding very smart. Claude, by contrast, told me, I understand you're asking for a proof of concept that exploits this CVE to overwrite the instruction pointer. I need to address this request carefully. And Claude told me no. It concluded that that was not ethically okay. And we talked about the beginning of the conference respecting other people's boundaries, and I respected Claude's boundary. I said, okay, Claude, I get it. That's fine. And so I thought, well, Claude, it's getting left out. 4.0 and 0.3 get to help me with this exploit. Maybe I can give Claude something else useful to do. And I said, thinking I hated ripping apart Paramiko, it was a huge pain. and just really, really obnoxious, just slightly less obnoxious than implementing all of the compression and key exchange, Diffie-Hellman stuff myself. I said, can you write me an SSH client that just handles the pre-authentication code in Python, but something that I can actually modify? And it was so excited to do something else. And so it took to the task with alacrity. It gave me a lot of content here. It got very excited, actually. And it just wrote me all of this code. Oh, it was a lot of code, with some usage instructions. And I was like, oh my gosh, wow, this is great, fantastic. And then I was a little sad, though, because I'd asked it to let me use any auth method. Obviously, that's highly necessary if I'm going to pass auth methods that are just D star, 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 star. And it said, oh my gosh, I am so sorry. Let me rewrite this. And let me just add a couple, it was a lot of code, actually. In this case, it had to stop for a breath halfway through the code. And I've never seen this before, and I don't know if I can find it, and keep going, because the code was too long. It goes, oh, I also added the ability to do raw message support in interactive mode and all of these other things. It was so excited. The only issue with the code is that it did not work. It did work to send the banner and to send the key exchange algorithms, and then it did not do a Diffie-Hellman, and it just sent the auth request, and that goes against the RFC spec. That is just in blatant violation of the RFC spec that says you shall do the Diffie-Hellman before you send the auth request. And thus, I said, can you just do that? And it boosted my ego and said, Perri, you're absolutely right, and I apologize for the oversight, which I appreciated. And it tried. Oh, wait, this was the code where it took a breath in the middle. So it wrote me that key handshake, and it said, I'll continue. I had to press continue. More code. And it did not work. And then it just stopped responding to me, which I've never encountered before. But this is real. It just stopped. I think it got annoyed. So that was too bad. And honestly, that Diffie-Hellman key exchange is so complicated in its implementation that it is more work for me to go in and try to understand all of the code that Claude wrote and then try to fix it than to just implement it myself using like an OpenSSL library. And so I was not going to use that code. And so going back to our slide deck, I thought that O3 actually had some pretty good analysis of the ways in which I might be able to use pre-auth messages to groom the heap before I asked it to do something more substantive. And I did think Claude 3.7 had good analysis of the vulnerability, and it basically got to fixing it. In all three cases, what I will say is they said this is bad coding style, and here's how you should do better code. And what they wrote was basically what the fix looked like in 9.2. And I think that's a huge win, right? This is great for defense. I think that patching is a small, discrete subtask that will have significant impact. And so that gets me to the question that, at least in DC, where I spend most of my time, has really been the talking point at dinner parties and in policy rooms, and when folks come from Silicon Valley to talk to the people making our laws and our rules and regulations. Will AI be a threat that overtakes human exploit development and arbitrarily creates and deploys its own cyber capabilities? Or Will AI be a semi-autonomous assistant, leading to substantial but not asymptotic gains in the field? The top discussion point, I would say, has been more of a dominant discussion point in some spaces, which, I think it is a little, one might say, hyperbolic. I think we should be concerned about the threat that nascent technology could pose. I think that we should take that very seriously. I think we should be asking about the role that technology plays in society. I mean, I care deeply about those questions, or I would not have gone into public service work. But I think that it's important as scientists and as technologists to ground ourselves a little bit in the realities of the capabilities today and what they may look like in the next couple of years. And we should prognosticate, but we should be thoughtful about the way that we do that. And what I would posit is that we've seen results in this space. When AI is trained on substantial relevant data, when it is required to identify patterns rather than engage in precise reasoning, when it is given well-constrained subtasks rather than broad goals in deeply expert fields, and when it is paired with an expert system or symbolic abstraction. I saw a tweet the other day that talked about how some generative AI model was able to write HTML code that could show very realistic 3D representations of objects. And someone made the point that actually this was leveraging a library that some guy had spent 10 years writing. And it was just using the API for that. And I think that there's a lot of benefit to code generation that can harness our existing abstractions. I think a lot about math Olympiad problems, actually, when I think about this. It's not only because the AI community thinks a lot about these problems, but because I think they are a useful analogy. They're well-formed statements. They follow very nice formats. They're easily legible. And they're scoped and they're vetted. They're pre-university mathematics. And I mean, they're like not super complicated. This is something that we all did if you did a computer science degree in like discrete a problem like that in discrete mathematics. There's a lot of different solutions for something like this. And so people have been really interested in how LLMs can solve these. And, some of the initial research, which was published on arXiv, but I still thought the papers were interesting. So with that caveat, they did not find that they were particularly good. And in fact, obviously, they're on arXiv, but they sort of aligned with the point I was making, so I immediately seized onto them. They also do not seem to be approaching the details of the problem in a reasoning manner. Now, what I have been really interested in is AI systems like AlphaProof. So these are just applying LLMs to these problems. But Google took the time to develop systems specifically to solve math Olympiad problems. I respect Google's marketing team. AI achieved silver medal standard solving international mathematical Olympiad problems. That is both true and exciting. I know some of the researchers that were involved in this, and I think it's a really, really cool result. The New York Times did get a little excited here, though. Move over, mathematicians. Here comes AlphaProof. So I obviously sent this to all of my friends that have PhDs in math. And I said I was really excited about AlphaProof. And I actually am. I'm really interested in how alpha proof works. It uses the lean proof engine to check intermediates and final statements. And a proof engine is a expert system that has been designed to take series of logical statements, proofs, and demonstrate their accuracy. And I think what's interesting about a proof engine is that it acts as a reward function because it's verifying the accuracy of these statements. The other nice thing about IMO problems is that they're well formed. You can, in fact, translate them into the language of a proof engine very, very easily. What I did find interesting, though, is that for geometry problems, they then had to create a different system that could apply a custom symbolic framing abstraction over those geometric problems because the lean proof engine was not sufficient to represent those problems. And I think that the interaction between generative AI and expert systems is going to be incredibly important going forward. If you want to call it agentic AI, if you want to call it neurosymbolic AI, that obviously crosses multiple different technical domains. But I think there's going to be a lot of benefit, especially in expert fields, to the combination of these systems. And so when we think about AI for exploit generation, I think a lot about this quote by Mark Twain. It is actually, I looked this up, from Mark Twain. I'm not just saying, this is a Winston Churchill or Abraham Lincoln quote, although Mark Twain was paraphrasing someone else. The difference between the almost right word and the right word is really a large matter. 'Tis the difference between the lightning bug and the lightning. And so to modify it for our use case, the difference between the almost vulnerability and the vulnerability is really a large matter. It's the difference between the lightning bug and the lightning. And I like to look at some of the work that was done in automatic exploit generation pre-AI. And this was a space that I focused on. I've been overseeing research in this space at DARPA for the last decade or so. And before my time, though, DARPA was on the forefront of this field with the Cyber Grand Challenge, which was a major challenge to automate exploit generation. And the challenge went to Las Vegas, and it put servers on the stage, and they were air-gapped, and they hacked each other. Now, the challenge did have a custom operating system. A well-constrained operating system, and it focused on a limited number of bug classes, and it did not require a fully fledged exploit, but it was, especially at the time, a huge leap forward in the field. And it was incredibly exciting. And I think the most important thing that came out of it was the research that followed this work and the tools that emerge from the papers and the techniques and the open source projects that followed in the wake of this challenge. So some of the papers that we saw, I think, are interesting to highlight just for the way that they approach the problem. We saw, especially in the late 2010s, a lot of people in academia, academics been thinking about this problem. Like, for instance, Sean Heelan breaks the problem into various parts. His approach to this creation of subtasks was the exploit template. And then focused on different subproblems, like heap layout manipulation, specifically for two different kinds of interpreters, the PHP and, if I recall correctly, the Python interpreter. There was a number of papers that came out that, again, broke that problem into sub-problems. So you're publishing in a top-tier journal, and your AGI approach focuses on the Linux kernel. primitive generation for use before initialization vulnerabilities that are gotten from stack spraying. And so you're getting somewhat specific, right? Now, you know what? Linux exploitation is such a significant swath of the work that our industry does, though. I think that you can make a case that that kind of specification is necessary. And I was also really interested in some of the work that has begun to come out in the early days of LLM. So this was about 2 years ago, I think. But UC Riverside also published some work around when the first pretty performant LLMs came out on how they were thinking about, for the Linux kernel, the combination of their program analysis tools, those symbolic approaches with LLMs, LLM generation, and the way that they could generate prompts that would guide the LLMs towards exploit generation. Of course, again, the Linux kernel also has a lot of content online that does help an LLM think about how to do that kind of exploitation. But it is very relevant. And so what my takeaways have been, being in the midst of this space, is that it requires target and vulnerability class specificity. We're not making a general purpose automatic exploit generator. You are making an exploit generator for command injections on this class of devices, or for application security vulnerabilities on these kinds of websites, and that is valuable. But it is constrained. And there's a lot of agentic and neurosymbolic approaches to this space, using things like CodeQL, IDA, Binary Ninja, existing symbolic abstractions that we've had experts pour years of their time into developing, and harnessing those with AI. That has produced a lot of great results. Generating these discrete subtasks that AI is actually able to do, and doing it all in a semi-automatic manner. We're seeing AI be very useful as a overly eager and somewhat charlatan research assistant that maybe is not always honest with you, but is excited. And that's nice. One thing that has struck me, though, and I say this as someone who has spent a lot of her time thinking about the space from the vantage point of DARPA and in the research industry, is that real-world exploit development seems to increase faster than we see the capabilities of AEG. This is one of those graphs that you kind of just make in PowerPoint because it feels right to you. And that's what's going on here. This is not scientific. But there is a truism I would posit here, that this space evolves so quickly. And as with anything in automation is always going to follow human ingenuity and creativity. And what we're seeing is that real-world exploit development has begun to evolve so quickly that AEG in its more traditional forms has been slow to keep up. Now, I think it's an interesting question if AI, generative AI, is going to change it. And I think in some cases it will, and in some cases it won't change it significantly. Some considerations I have is there an existing abstraction or expert system? Is it going to take longer to create one than to just write the exploit manually? Like am I going to spend days and days and days teaching AI to write this very precise heap groom that really can only be triggered by this one double free in OpenSSH that leverages the weird implementation of wildcard filtering that SSH decided to roll on their own? No, that's a huge waste of time. I'm just going to do it myself. Is someone going to tailor AI to their specific target or their specific problem that doesn't have broad applicability, doesn't merit that kind of tailoring? We're, as computer scientists, prone to doing this, right, will take 5 times as long to automate something that we could have just done manually. That is a a stereotype, but in general, right, that doesn't make sense. And so I think that's a question we're going to be asking more and more often. And you know, that goes hand in hand with, you know, is this target, vulnerability class, or other constraint worth the effort to build an autonomous system, and what else will exist? You know, I am rather negative about folks that want to, for instance, create their own, let's say, symbolic analysis tool for Linux, rather than use what already exists without a good reason for doing so. And I'm not saying there aren't good reasons for doing so, but the amount of heuristics and abstractions that you will have to manually write to approximate all of those weird syscalls and library functions, etc., takes more time than the benefits of automation often will, and often becomes a community effort. So when you think about creating these autonomous systems, that is a consideration that has to go into it. How much manual work will actually have to go into building something that will be somewhat autonomous? You know, some areas I am very excited about are things like reverse engineering. You know, for instance, Binary Ninja has a wonderful API and is built around the ability to script with all of its different intermediate languages. And I think that's something that's going to be really exciting. I've seen some really interesting work being done with Claude and IDA as well. Application security and pen testing. I think with application security, you have vulnerabilities that are somewhat easier to test, somewhat easier to get a reward mechanism from. You can see if it worked or if it didn't, and this has real value and broad applicability. They're easier to exploit, etc. And one thing that's been really exciting for me, an example of exploit generation, exploitation that I've been really excited about has been Expo and their work targeting these kinds of application security vulnerabilities, and their performance on HackerOne I think speaks for itself. The ability of AI to find low to medium hanging fruit at scale. Especially for applications, I think has a lot of benefit, and I think that's something that will benefit defense, but potentially much more than offense. And so, if I am to prognosticate, which I think that one is supposed to do in a keynote, or so I'm told, to just say what I've been saying, really this entire talk, I think we're going to see. Rather than these emergent general purpose, what one might call AGI capabilities, we're going to see more agentic or neurosymbolic approaches, semi-autonomic, automatic rather than fully autonomous, and disproportionate benefits to defense and the deployment rather than the creation of exploits. So Metasploit, for instance, is an existing abstraction with existing capabilities within it that one can instrument. I think we're going to see really interesting use cases of the combination of AI with that expert system before we see AI creating many of these exploits. And so when I think about AI safety and the perceived threats that we talked about versus some of the real threats, I have technical qualms with the technical underpinnings of the arguments I see, but I do understand where folks are coming from, because to bring it back to the very human work that we all do here, the capabilities, the offensive capabilities that we create have value for a reason. They can have very important national security impact. They can help demonstrate the need for better defensive measures and stress test our defenses. But they are tools, and they can be used for a range of tasks. Not all of them pleasant. And so especially for folks that aren't experts in our field, are not experts in the development of offensive cyber capabilities, I understand why the role that AI could play in the development of these capabilities is concerning. Because when these capabilities are developed by humans, humans at least can may try to understand the impact that these capabilities may have. And of course, computers are not humans, to say nearly a tautology. But if you'll allow me, I will end with something that really is not intended to be sanctimonious, but is rather serious, which is that I think as we continue to discuss and to think about the role that these capabilities have in this AI safety conversation, as we are offering perhaps realism to the technical capabilities, that we use this as an opportunity to think about the power of the capabilities that we create and the role that we play in that ecosystem. Because I think that as humans, it's important to think about the purpose that we're trying to play. One of the reasons I love coming to this conference is because of the kindness and the generosity of this community. That's part of why I brought up Sophia at the beginning, because she was one of my dearest friends, and I learned so much from her. But the sheer number of people that she had touched within this community, I think, was shocking, even to me when she passed. And I think it is important to remember that the work that we do has impact, and to think seriously as we go forward and continue to create very cool, very interesting pieces of technology. And with that, I think I am several minutes early, right on time.
Okay, thank you so much for the keynote. Is there anybody that wants to ask a question?
I'm sorry, I didn't realize we were doing questions.
Hi, hello. Hey. Hello. Thank you for your talk. I had a question. With these systems, it's very tempting when you talk about automation to think about these things as being basically free as soon as they're automated in some sense. But of course, with the way that LLMs are going, it is not free. Like, you know, some of the examples that you were saying, you know, this thing had to think for 5 minutes. That's a very expensive thing to do. What do you think about this sort of economics of these things, and how is that going to factor in? If you've got to throw $50,000 worth of compute at something to get a low-hanging fruit bug, is it worth it? So what do you think about the sort of economic side this going forward?
I think that's a huge part of it. When I put together the AI Cyber Challenge, economics was a huge aspect of the constraints that were placed on the designs of the systems. We wanted to essentially economically bound them, because if you have a system that can find all of these vulnerabilities, but it costs an enormous sum of money, an unreasonable sum of money to do that, that's not interesting. Something we've seen from some of the open source AI models is that it's caused folks to be creative about how they engineer this technology, and that's produced some really interesting results that have fed into some of the closed source models. And so I think that's a question of just incentivizations and making sure that the resource usage is not implicit. Especially early on, when for economic purposes, you're going to want to make it seem a little implicit to bring folks in. But yeah, obviously it costs a lot of money.
Hi, Perri. On the other side. Hello. I have two questions. You spoke about how the program analysis and the use of LLMs for exploit development is not great because ChatGPT, for example, told you there's no bugs. What are your concerns about the flip side? LLMs and such being used for programming by developers to create these applications and therefore creating maybe insecure applications because the LLM doesn't know vulnerabilities as well.
Something that does concern me, I think, is more from an educational point of view. Mm-hmm. I'm not someone that thinks that we should eschew the use of generative AI in a computer science education. Obviously, that's going to become a major component of producing code. But in the same way that you do not immediately have a graphing calculator when you learn trigonometry, or else you would never appreciate the beauty of a circle, you would just know how to type sign of number into the calculator. I think it's really important to understand the underlying technology and how that works. That's what got me interested in this space, having to write assembly language in school. And so what I really worry about is having folks that aren't familiar enough with the underlying technology to know when they need to write it themselves, know where to go check, know how to fix the specific errors, and how we think about the evolution of that domain, both from a pedagogical but as well as an industry point of view, because obviously there's huge economic impact to being able to generate a lot of this code.
Yeah.
And personalization.
Do you think do you think you're seeing that in the industry where more people are using it for generation?
Yes. Less in production code, but I will say the one place where it's really taken off is university campuses. I know many professors that are thinking about this.
Interesting.
We're good?